Hello everyone! Today we are going to be talking about holes in rational functions. And no, they are not things that you dig in the ground. What we are going to be doing in this is factoring and maybe some choo-choos, if you know me any well. And when that happens, it's going to create a hole. So just in case you don't know what a rational function looks like at all, they look sometimes something like this, where it has a part over here and a part over here. Sometimes there's like more than one vertical. So you'll have like a part up here. It'll go through the asymptote in the middle and then like be over here. And there are just all kinds of funkiness. And weird things can happen, but one of the things that can also happen is maybe it looks like this, except there's also a hole right there. Which is to say that if you go to that x value, it's undefined. Normally, undefinedness happens at vertical asymptotes, because, you know, if you go to, I don't know, we'll just call this -1, there's nothing at -1. But then it happens if you go to -2, there's also nothing at -2, but otherwise everything around it would be there. And that's called a hole. And you're going to draw it just by doing a circle. As you did in before, you know, filled in circles means something exists, open circles means something does not. So here we go. Sometimes the function can be simplified via choo-choo. If this happens, it creates a hole instead of a vertical asymptote. Always double check in your calculator's graph and table to make sure everything was out all right. So here we go. In this first question, nothing cancels out immediately, but it turns out that the bottom is factorable by difference of squares. So the square root of 4 is 2. So you get x plus 2 and x minus 2 in the bottom once you factor it. But the top also had an x minus 2, which means these two things cancel out. In which case, all you have left on top is nothing, meaning a 1. And on bottom, you have an x plus 2. So that would be like the new function you use for everything else. Like if I wanted to find a vertical asymptote, I'd set it equal to 0 and get a vertical asymptote at -2. But I don't care about that right now. Excuse me. The hole, however, the way you find it is that once you cross something out, like in this case, we crossed out x minus 2, whatever you cross out, you set equal to 0. Kind of like what we would do for a vertical asymptote. If you set it equal to 0, you would add 2 and you get positive 2. And that positive 2 is the x value, right? Because we do say x equals 2. So the x value of the hole is 2. But that doesn't tell you like where the y value is. Because remember, we're graphing. And when you graph things, you can say, okay, x is 2. Now what? Don't know. It's not an asymptote, right? We need a y value. Is it up? Is it down? Is it right here? We don't know. So we have the x value, but we need to find the y value. But this is something common in math. It's not just this unit. It's anything. Anytime you have an x value, how do you find the y value? The answer is you plug it in. So once we have this x value, if we plug it in, we'll get the y value. So in this case, we'll have 1 over 2 plus 2, which is 1/4. They usually are fractions, so don't freak out too much if you get one. So there you go. That's where the hole would be for that one. Once again, you can check in a calculator or graphing utility, and if you go to where x is 2, you should see undefined. Because remember, holes don't exist. It's where something doesn't. So on a calculator, if you go to 2, it should not say 1/4. It should say error or not defined, something like that, because it's not supposed to exist at 2. It's just if it did exist at 2, the value would be 1/4. Like here, when I was talking about, it would be the hole. It's like this is at 2 1/4, but it's an open circle there because there's nothing there. And yes, I do know that's not 2 1/4. Here, x plus 5, nothing to cancel. X minus 1, choo-choo. Those cancel out, and you get x plus 5 over x minus 3. we canceled x minus 1. So if we set that equal to 0, we got x equals 1. And now I'm going to take that 1 and plug it into the new equation. Always plug it into the new equation. If you plug it in here, nothing will happen. So then 1 plus 5 is 6. 1 minus 3 is negative 2. And 6 divided by negative 2 is negative 3. So that means if you were to go to 1, 1, 2, 3, there'd be an open circle here. Like that. Okay. Lastly, here, it looks like the top is factorable. How do I know that? Because I would not give you a problem that's not factorable, because that's the whole point of this unit. I mean, it's because of my knowledge of math. Yeah. What multiplies to negative 48 and adds up to negative 2? I don't know. 1 and 48 maybe. 2 and 24. 3 goes into it, let's see, 1 16 times. 4 goes into it 12 times. 5 does not. 6 goes into it 8 times. And that's everything that multiplies to 48. It looks like it'll have to be 6 and 8 then. But one of them will be negative. And that'll be the 8. So x plus 6 and x minus 8. Here in the bottom, I noticed that they're all even, so I'll factor out a 2. And what multiplies to 16, that's just going to be 8 and 2. And then to make the 6 negative, that's going to have to be the negative 8 and a positive 2. So it looks like this time, what cancels? Yeah, x minus 8. And if you take that and set it equal to 0, you get x equals 8. But when you simplify, you still have on top x plus 6. And on bottom, you have this 2 and an x plus 2. So I'm just writing that down here, if you can't see. Boop. X plus 6 still on top, and the 2 and the x plus 2 on bottom. We're going to plug in 8. So put an 8 here, put an 8 there. 8 plus 6 is 14. And this will be 2 times 10, which is 14 over 20, which simplifies because they're divisible by 2. And you will get 7 over 10. And that's where the whole would be. So you would like go over 8 and up 7/10, which is not even 1, and you'd put a little circle there. Okay. So all together now, we will do everything we did in the last video and this one put together. Put some asymptotes, put some circly dealies, and see what we get. So for the whole, once again, we're going to go ahead and factor this thing. How do I know it's factorable? Because of course it is. What multiplies to 12 adds up to 7. That'll be 3 and 4. To make sure it gets to negative 7, though, that'll have to be negative 3 and negative 4. It looks like nothing cancels. Nothing cancels, which means there's no holes. Yay! Vertical asymptote. That's when you set the bottom equal to 0. So if you set the bottom equal to 0, you get x equals 3. And if you set this bottom equal to 0, you get x equals 4. Right, so m equals 0, add 4 or add 3. Horizontal asymptotes, that's when you compare. So here, there's a 1x squared. This has a 0x squared to match it. Which, let's see, do you remember 0 over 1? Is that 0 or is it undefined? It's 0. So horizontal asymptote is y equals 0. Or, of course, you could use a little cheaty-weedy. If the degree is bigger on bottom, the horizontal asymptote's at y equals 0. So we'll graph all of this stuff. X equals 3 is right here, 1, 2, 3. X equals 4 is right here. Oh my goodness, why did I do this to myself? And of course I messed it up. And horizontal asymptote at y equals 0. So we get that. 2 asymptotes here, real close together. 1 asymptote right there. And that's what you would get. You know, you can use a calculator to find the rest of where it's going to be, but that's the important part for this lesson. Excuse me. Domain then, there's a cheat way to do it for the domain. What you can just say is the domain is everything except these x values that we said it can't be. Because remember, domain is x values. That's the definition. So if there's an asymptote at 3, that means x can't be 3. If there is an asymptote at 4, that means x can't be 4. Ta-da! If there was a hole, we'd have to do the same thing. X does not equal whatever the x hole is. Okay. For this one, you can factor out a 2. You get x squared minus 4. This will be x plus something. Multiplies to 8. Would be 4 and 2. It looks like this one factors even more because it's a difference of squares to get x plus 2 and x minus 2. So then I'll see if anything cancels. All right, this is your one chance to press the mute button before it happens. Chugga, 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 chugga. There we go. So that cancels out, and we will have a 2 on top with an x minus 2 still. And on the bottom, an x plus 4. So this time something did cancel, the x plus 2. And if we set it equal to 0, we get x equals negative 2 for the whole. Now that we have the negative 2 for the whole, we can plug in negative 2 there. So 2 and then negative 2 minus 2 over negative 2 plus 4. So once again, I'm just plugging in negative 2 for where x used to be. And this will be 2 times negative 4 over 2, which those can cancel, you just get negative 4. So negative 2, negative 4, open circle. Yeah. Vertical asymptotes, we're going to go back to this thing, our simplified version. And if we set the bottom equal to 0, we get x equals negative 4. So, negative 4. Okay. Horizontal. If we go here, it looks like it's a 2x squared over a 1x squared. They match already, so it's just 2 over 1. 2 divided by 1 is 2. So y equals 2. So 1, 2. All right. So we get those. Now, actually, you don't even need a graphing calculator to do this part. Since we have an asymptote here and a hole here, you can know that this part of the graph has to be here because it wouldn't make sense otherwise. It has to get at least close to the asymptote, and it has to get close to, let me just make these a little bit thicker. There you go. It has to go towards the asymptotes, and since there's a hole there, it has to be in that section. Which means it's very likely the other section's going to be here. You can't say for certain in rationals because rationals are weird, but it's probably going to be there. But you would just check on a graphing utility for now. So domain, it can't be the vertical asymptote, so I'll write x does not equal negative 4. X can also not equal negative 2. So once again, this is an x value. Holes don't exist, asymptotes don't exist. So it can't be this negative 2 and it can't be that negative 4. For range, similar. The range can't be the horizontal asymptote. And it also can't be the y-coordinate of the hole, because once again, range is y values. So the y value is -4, so y also does not equal -4. Because as you can see, at -4, there's no y value. Just like at 2, there's no vertical asymptote, horizontal asymptote. There's no y value at 2. There we go. Okay, yeah, that's it for this video. Have a good one.